But yeah, we met with these amazing folks that I never met in person. We are at Nuremberg at Embedded World, and we decided to do an online workshop for all of you, like a virtual one. We are going to mix amazing technologies such as Bluetooth Wireless, Edge Impulse, Datacake, balena, and so we are here to do this together. Yeah, let's do quick introduction, just in case people don't know you.
Yeah, so my name is Brandon Tatram. I work on the developer experience team at Bluetooth Wireless. That's me.
Yeah, Simon Kemper, that's how you pronounce it in German. I always pronounce it English way. I'm the CEO and co-founder of Datacake, the IoT platform for IoT devices.
And this is Mark Pose, developer advocate at balena. So let's start.
Great.
Would you like to start introducing? Well, maybe let's explain what we are gonna do.
Yeah.
I have here on my table, if it works, a Raspberry Pi with later we will do like a zoom on this Raspberry Pi with a Bluetooth wireless Pi hat and with a note card, which is the Bluetooth wireless modem that you're going to explain in a second. We have a camera, and this is running actually a machine learning model that detects digits. It's an OCR machine learning model. In a really simple way, we can do an OCR system that detects numbers and send this data to the Node Hub that you will learn in a second what is this. And Node Hub will route this data to Datacake, and we will visualize what are the numbers that detect this camera with this machine learning model running on the edge with Edge Impulse and balena. Okay, everything is on a GitHub repo, so I'm going to share this very soon, so you can deploy it in your place and you can contribute and whatever. But I think it's time to start.
Great. Yeah, so I will share some slides, and I'll spend a couple of minutes just very briefly walking through the note card, Bluetooth Wireless, and spend a few minutes actually taking a note card, getting it online, and then we'll move into the balena and Raspberry Pi side of things, and then wrap up with the Datacake visualization piece as well. And this is it's exciting to be with these guys. I've known these guys for years now, but finally getting an opportunity to meet in person and do this workshop is kind of fun. And really, all of us are here. We're all in this space, and we do what we do because we're trying to build tools to unravel this problem of complexity in the IoT space. This problem that we have of never really being able to get out of pilot purgatory or prototype purgatory in many ways. And complexity is a topic that we talk about a lot at Bluetooth Wireless because our CEO is actually known for a quote that he minted about complexity years ago before he was even in the IoT space. It is complexity kills. It sucks the life out of developers. It makes products difficult to plan, build, and test. And that's definitely something that we have all experienced as developers. Even if you haven't spent your career working in the embedded or IoT space, you have felt this when it comes to trying to deliver things. And this is really the idea for Bluetooth Wireless. We were built around this idea of creating simple cellular wireless IoT solutions. And so the company was started in 2017, and really on this principle of making wireless IoT easier for developers and more affordable for all. And it starts with a product that we call the note card. So we were built around this idea of making IoT easy and affordable for developers, making sure that we can secure data from device to cloud, making sure that developers could rely on low power hardware that required no configuration, providing an unmatched developer experience. And the note card is really the center of all of this. It's a low power system on module device. It has global cellular GPS, cellular and GPS or Wi-Fi. The Wi-Fi note card is the black PCB device in the back. The cellular note card is the green one in the front. Every note card includes 500 megs of cell data and 10 years of service. The price is on the tin, as they say, so there's no subscription fees, no other monthly fees that you have to pay for actually activating or deactivating devices, things like that. And it's got a 100% JSON-based API. And one of my favorite features, is someone that is a bit of a language polyglot myself, is we have support for Python, Go, Arduino, C, and C++. We have SDKs for really whatever your preferred programming language is. And on the cellular side, we have support and coverage in over 135 countries and support for NB-IoT, LTE-M, and Cat1. Now, the note card is the starting point, but as you notice from the last slide, that the little connector on the edge connector is an M.2 edge connector, and this is really easy for folks that are building their own, designing their own boards for a scale solution. But for many customers, they start with a prototype, right? With actually trying to build that first solution or the first 10 or 20 or even 100 that they deploy in the field. And so we also create products called note carriers that are designed to be dev boards for easy prototyping. It starts with, and there's 4 different families. There's the note carrier A, which you can use with any microcontroller, and it has onboard antennas from our partner Ignion. The note carrier B, which is the small one here in the center, which is our small form factor note card. There's a note carrier F, which is not on the slide, but I do actually have a preview version of this board on the table here. And then the note carrier Pi, which connects into any single board computer like a Raspberry Pi. And that's actually what Mark has and that we'll be using for the next demo here. Now, the note card is designed around making it really easy for you to connect your sensors to your ultimate cloud applications. And the way that we enable that is with a service called Note Hub. It allows you to route data to any cloud app, to manage fleets of devices, to perform OTA, firmware updates, and to make secure communications not only to the note card, from the note card to Note Hub, but in back. And every note card command or every event that you send into the note card is adorned with location information, tower information, all kinds of good stuff that you can use for your applications. So, and as I mentioned earlier, it's a 100% JSON-based API. So if you send a request like card.location to the note card, what you get back is information about the status of the GPS signal, the latitude and longitude of the device, and the time that information was captured. And this is a really powerful way of working with a device without having to memorize AT commands or talk to a module manually. So what this ends up looking like for the developer when it comes to communicating from a microcontroller to the cloud is that you can choose any microcontroller, any sensors, your language of choice, and send JSON requests to the note card. The note card then receives those requests and uses its secure connection over the cellular network into Note Hub to forward that information into Note Hub. And from that point, then you have JSON that you can then send out to your ultimate cloud service, whether it's AWS, Azure, GCP, or my personal favorite, Datacake, not just because Simon is here, but because it's a great tool that we really like to use. So really any cloud service. We're not trying to be a platform. What we're trying to do is provide a secure middle piece between your sensors and your cloud applications so that you can very quickly get connected to the cloud and rely on easy communication. But the note card is also bidirectional, so you can communicate from any cloud service and send JSON events like this data.qi note that then gets communicated back down to the note card itself. So you can do things like send notifications to actuate your projects, etc. All again using the note card and Note Hub. So then ultimately what you get out of the other side of this is you get to build your applications your way, build the things that you're actually interested in, build the visualizations that you care about, because that's really what matters. So you can focus on building your solution, focusing on the solution, not how you build it. We do a lot of examples of the kinds of projects that we build, that customers like to build in Hackster. So you can learn more about the kinds of things people are building with the note card at hackster.io/blueswireless. But what I really want to do is spend some time actually getting hands-on and showing you what this entire experience looks like. And so I have on the desk here next to me, I have a note card. It's a Wi-Fi version of the note card that is plugged into the note carrier F, which is a new note carrier that we'll be releasing later this year. And it is plugged in over USB and ready for me to communicate with it. When most customers get their first note card and note carrier, what they'll do is they'll go to dev.blues.io to our quick start. And when they end up at the quick start, they'll choose their starting path, and then they'll land here in a browser-based experience. And one of my favorite features about our developer portal is that we have a built-in browser-based REPL. So as long as you have a serial cable plugged into the note card and you're using a browser like Edge or Chrome, you can actually make a USB serial, open up a USB serial channel into the note card and send commands to it.
device that I'm gonna point the camera.
Oh yeah, okay, all right. So yeah, Mark's gonna do a close-up of the note card and note carrier. So you all are getting a first ever sneak peek of a prototype version of a new note carrier that we're going to be releasing later.
Oh, so this is
it's not available for sale yet.
Oh wow.
Yeah. So everybody's getting a sneak peek right here. That's why you come to these workshops, right? So now that I'm connected, what I'm going to do, you can go ahead. Yeah, take it. Sorry. Is I visited the quick start and I can click connect. And because I'm plugged in over USB, I can see that I have my note card here. I can connect to it and I'll see that I've got it because right away it'll tell me this I've connected over serial, and it tells me the device UID of my note card and that it's a Wi-Fi note card and the firmware version that I'm running. So I know that I'm connected and I can proceed from here. So as I'm going through the quick start, the next thing that I'm going to do is create a Note Hub project. As I mentioned before, Note Hub is the cloud piece of the device to cloud data pump that is the note card in our ecosystem. Note Hub is where I will receive events so that I can then forward them on into another location. In the case of today's workshop, that's going to be Datacake. But the first thing that I need to do is create a project. So I'm going to click on this Create a Project button. I'm going to call it IoT Stars Workshop. And you'll notice, actually, I don't have to do that. Do the thing for me. There we go. IoT Stars Workshop. I'll create that project. And what that's going to do is it's going to give me a product UID. That product UID is the identifier that the note card uses to when it connects into our Note Hub cloud service, it knows where all that data needs to go to. It knows where it needs to route things into our cloud service. So I need that to then go into the next step of the process, which is to actually set that product UID on my note card. And you'll notice here that, again, this is all 100% JSON. Inside of the quick start experience, I can click the try button and I can change this default product UID here to my product UID, hit enter, and an empty response means that worked. And I can validate that by starting a sync. I'll hit sync right here. And if you were going through the quick start, what you would usually see is use some commands telling you to do a hub.sync.status and see what's actually happening. But I'll give you, since this is a workshop, I'll give everybody watching a little bit of a sneak peek at a trick that you can also do. If you type in T in the web REPL, that actually turns on trace mode, and you can see everything that's happening behind the scenes of the note card. This is the advanced view for workshop participants only, right? You guys are getting to see this, it's special. But so anytime that I actually trigger a sync, and I'll do that again, it makes that connection to the note card. You'll see how quickly it happens. So I'm connected with the Wi-Fi note card, but even if I was on cellular, and you'll see this in a bit, Mark's note card is connected and it's happening just as quickly. It's just sending small payloads as I go through and do a sync. But the next thing that I'm going to do, now that I've validated that, is I'm going to send a note to the note card. And that's the primary way that you send your sensor data to the note card and then into Note Hub. Is a very simple JSON command called note add. And all you have to do is basically send any arbitrary JSON payload, JSON body, as your arbitrary data, and you're off to the races. So I'm going to just pick some dummy temperature and humidity data. If this temp is in Celsius, that's really hot. I don't think it's 35 here. You think it's maybe like 20? Is it close? Maybe
it's close.
28,
it's close.
30, yeah.
Well, let's say it's 30.
We open the windows, but
it's still a little warm. It's not as hot as it is back home for me, and maybe 65% humidity. I don't know, maybe it's drier than that. So I've sent that note to the note card, and now it's queued up and ready to go. But it's not yet on the note card until the note card syncs. There's a couple of different ways that you can do that. You can have your note card continuously connected to Note Hub, so it's always syncing automatically. Or you can have it set in periodic mode if you're running in a low power application where you're maybe writing data to the note card several times a day, but you only want to send it up to the Note Hub 2 or 3 times a day. But the note card can be that queue to hold on to the data until it's time for you to actually get it in to Note Hub. But I can initiate another sync, and you'll see now through the trace mode, if I look at the sort of behind the scenes view, you can actually see that one note was sent to the Note Hub, to Note Hub, and it should be actually there waiting for me. So I can view that by going now back into Note Hub, and if I refresh my project here, you'll see I've got the device on. It's in Nuremberg. It is online, and if I look at events, I can see not only do I have the session information and all the good environment variables and stuff that shows up when the note card comes online, but I got a geolocation. I got a Wi-Fi geolocation note, which is another one of those free features that we provide for all note cards, and my data. So what's cool about this is what came into NoteHub is not just this temperature and humidity, but if I actually click on the event itself, and then I click on the entire JSON, I can see the body, but I can also see that I have a triangulated location. Here's the latitude and longitude. That is a Wi-Fi triangulated location. So it was actually, I don't have GPS on this device, but it was able to actually use Wi-Fi access points and the publicly available information about those access points to give me a more accurate location than the tower location that it also has as well. So, but I do have that information too. I have the lat and long from triangular. I have the tower information. Actually, no, it doesn't have. That's no tower. It's Wi-Fi. What am I saying? If it was cellular, it'd be tower information. This is why you do these things live, right? So I have that information based on the Wi-Fi triangulation feature. For cellular, what I'd be seeing is a tower ID and then that tower latitude and longitude and all that information in there as well. So again, all of this in just a simple JSON commands that then connected the device to the network, and I'm off to the races. So the next piece here is then doing something with all that data and building a richer application. So at this point, I'm going to hand things back over to Mark, and we're going to balenify this thing to have a little bit more fun with it.
Thank you. But actually, you did all of this without using any AT commands?
No AT commands. Yeah.
How do you do that magic?
The AT commands, somebody else wrote all those AT commands for us. They're all hidden in the brains of that note card. That's the beautiful part about it.
So that you completely reduce the friction to any IoT developer.
Absolutely.
To
yeah.
connect over cellular or Wi-Fi connectivity.
What's cool about it is that if you do actually watch the trace mode that I showed off come across, you can actually see some of the AT commands fly across, but I didn't have to write any of those. They're all taken care of.
You still can send AT commands, right? There's like an extraction. You can just use JSON and then send AT.
You can temporarily step into AT command mode if you need to do testing or diagnostics or anything like that. But yeah.
One of the things that I find super cool about the note card is if you have it like in a mode where it just sends like 1 or 2 times per day, but you're going to queue up nodes from a microcontroller, it sleeps in between and it just consumes so less power.
Yeah,
it's just so power safe.
Absolutely.
And that's really, I like it.
Yeah, when the cellular note card is in sleep mode and it's idle, it consumes as little as 8 microamps.
Yeah, it still responds to queuing up nodes.
And it still responds. Yeah.
It's impressive.
So let me show you very briefly how to balenify this. So actually, maybe you can introduce as well the node carrier for Raspberry Pi that you have at Blues.
Yeah, so our Raspberry Pi,
let me use the camera meanwhile, but yeah, please.
Yeah, so our Raspberry Pi note carrier I mentioned a few minutes ago has the 40-pin connector on it. So it worked great with the Raspberry Pi. You can use it with the Raspberry Pi Zero. You can use it with every other single board computer out there. It uses the exact same 40-pin header. So you can use it with a Jetson Nano. You can use it with a Rock Pi, but it works great with any Raspberry Pi. And it has every one of these Raspberry Pi hats also comes with a Molex antenna, an external antenna, so that you can connect the note card to it, and a Grove port, so you can connect an external sensor into your Pi-based application. But because this works with the Raspberry Pi, you can use JSON, you can use Python, C++, Go programs on the Pi and talk directly into the note card. And you can run full-on balena applications.
Yeah. So actually last week, sorry for this. Actually last week we published with Blues Wireless a balena hub blog where we reduce the friction to send data from a balena application over Blues. Because the Blues connectivity doesn't use a network manager as we used to manage all the connectivity at balena. So it uses I2C, right, to send the data. So we actually reduce as well to don't couple any application actually to the SDK from Blues. What we decided is to simplify it and offer an API, a REST API, so anyone could just send data to the Blues block or to the Blues container running on on their fleets of devices, and then just simplify the way of sending data.
And I just posted that blog post in the chat too, if anybody wants to see.
Yeah, so if you go to, let me show that. Yeah, let me share my screen. Sorry for the effect. Sorry for this. So, yeah, let me do a brief introduction. If you don't know what is balena, I'm sure that everyone knows, but we want to reduce friction on everything that we do. We basically want to reduce friction to IoT developers who are managing large fleets of IoT devices. And basically, if they need to update the software running on these fleets of devices, we can help there. We can reduce the friction on doing that. As well, one of the most popular software that we have is Balena Etcher. So if you use Balena Etcher, you already have used software made by Balena. So here we try to reduce the friction on flashing USB drive or SD cards to flash a new operating system you mentioned on your laptop or your favorite IoT device. We have plenty of products. So if you want to balenify your device, you will need an operating system called Balena OS, which is an open source Linux operating system optimized for IoT embedded devices. And it's basically based on Yocto. So that means that it's really easy, or kind of easy, if you know Yocto, to create the layers to balenify any device. Nowadays, we have almost 100 of different device types compatible with Balena. That means that, you can have a fleet of devices. You can connect more than 100 different types of devices with Balena OS. And another particularity of Balena OS is that it only runs containers. So all the projects that runs on Balena, they must run on containers. You cannot run anything on the host OS. And our container engine, basically, it's Balena engine. So with all the lessons learned that we got running since 2013, Docker on Raspberry Pi, we just made Balena engine, which is a super efficient container engine for IoT and embedded devices. We have amazing features such as the deltas and so on. So this is as well open source. And then we have Balena Cloud and OpenBalena just to manage your fleets of devices. Actually, the Balena Cloud is our premium feature, the only one that you will need to pay to use. But you can use OpenBalena, which is open source, and you can actually do the same with the same API endpoints, etc. Balena Edge, I already talked about it. And then Balena Fin as well, it's a result. It's the outcome from our lessons learned, helping our customers to grow. So we decided to do our own industrial grade hardware that it's basically a Raspberry Pi carrier board, but with some industrial grade. And basically the lessons learned that we got is that SD cards have problems, electricity bring problems to Raspberry Pis, and that sometimes Raspberry Pi are very power hungry. So it would be nice to sleeve the compute modules from the Balena Fin during some time, so we had a co-processor as well there. And basically, a Balenified device, it's running a Linux kernel, user space with all the network manager and systemd, etc. The container engine, and on the top of that, we have a supervisor, which actually it's connected to OpenBalena or Balena Cloud, just to create a connectivity, just to update the latest release or download the latest release into the device. And next to the container of the supervisor, which is invisible, we have the other containers of the application. Okay. We have as well Balena Hub, which is a marketplace for IoT application. And if you go to hub.balena.io and you go to the blogs, you can search there for the blues. I think we call it node card block. So you can find all the flavors for all the device types. This is compatible from Raspberry Pi 0 to Raspberry Pi 4. So I'm sure that if you want to test, Brandon and the Blues wireless team is going to be happy to ship you a node card with the Raspberry Pi hat. So it's time to build it. Actually, for the sake of time, because the Wi-Fi here, we were not sure if it was very reliable. I just deployed all the services on this device. So if you have a Raspberry Pi with you and you have a Blues node card and the Pi hat, you're going to be able to reproduce that. If not, you just can hack the code and just deploy. But what we are going to do is basically have a Raspberry Pi with all the hardware set up. We have a camera here, which is a Raspberry Pi camera. We deployed the application. You will see the 7 containers that we have. We train it with a machine learning model. It's actually an open source or an open machine learning model from Edge Impulse, from a developer advocate from Edge Impulse. And finally, yeah, we connect everything with the node card block. Okay. Actually, this is here. Everything it's documented. I'm going to share it right now in the chat. But if you go to my repository, I'm going to share it in a sec when I stop sharing my screen. And basically, what we are going to do, this is an OCR reader. So we are going to just turn on the camera. I have plenty of numbers here. We can test with the other numbers if you want. And then, yeah, we just are going to ship them to the Node Hub. And basically, yeah, this is completely documented here. So let me stop sharing my screen. I share again with the Balena Cloud, sorry, and then I give you Balena Cloud.
As a proof point, I'll just, as you're doing that, I'll say really quickly. We were talking a few minutes ago about the Wi-Fi triangulation, and somebody on Twitter actually looked up the latitude and longitude from that and figured out that we're in the Zollhof HQ. We're in the Zollhof Tech Incubator in Nuremberg based on the triangulated location. Yeah. So there you go, proof it worked. Yes.
I didn't know that it can do it.
Yeah.
It's actually, yeah, I need to figure out.
That's a newish feature.
Yeah. Okay.
Yeah.
Give me a sec because I think I have these open somewhere else. Yeah, it's here. Okay, cool. Okay, sorry, in a sec. Yeah, too many tabs open. Okay, so this is, let me change this, sorry for a sec. Yeah, let's do this, okay. Yeah, sorry, in a sec. Yeah, let me hide this just for the sake of, okay. We have actually some problems with the voltage. I'm not sure what's going on, but yeah, the supervisor is telling us that the device is under voltage. We have 7 containers, basically Wi-Fi connect in case that we change this device to another Wi-Fi. So how is it working right now, the connectivity? Basically, this device is connected to the Wi-Fi just to update the software, and the supervisor is connected over the Wi-Fi so we can get the logs and access to the VPN. But just to send the data, we have a flag on device variables that says, hey, we want the data from the OCR reader being sent to node card. So what we have, it's a container called node card here. So we just say to the processing service to send the data over HTTP. So actually, if we check here, we can see that, yeah, that EI processing is detecting 4, I don't know why, and sending actually this JSON to the node card service, and the node card service is sending the data to the node hub. Let's try another number, right? And then I don't know, what number do you want? Like 1? I don't know if okay, sorry. Yeah, and we have a public URL. Let's see if it works. We just had a tiny accident with the Raspberry Pi 5 minutes ago. Fingers crossed. We didn't pray to the demo gods, actually. Okay. So let's see if the camera wants to help us or not. It's okay. Yeah, maybe the angle of the camera is not perfect. Let's see what it's detected. Okay, so we have a 1 here, and it's detecting, let's do 8, maybe it's easier. Yeah, I don't know why the angle of the camera is not perfect now. Okay, I can do this. We had the right angle before, right?
Yeah, you had.
Yes,
Yeah.
before
someone just was walking around the.
I'm not going to name any names, but it was me.
Oh, you're gonna leave it right here. But let's do this. Maybe I can just move to Simon that can explain more about the. Now it detected. I don't know why it's detecting 7, but.
Yeah, but that's close to 8.
Actually, I don't know. Yeah, let's keep trying this, but yeah.
Yeah.
Please, I move. Yeah, all yours. Just explain next steps.
Yes. Okay. Let me first of all also switch on sharing my screen. I was disabling it for some reason.
Sure.
And it should work now. You should all be able to see my screen.
Yeah.
The standard things that you say if somebody shares the screen.
Mm-hmm.
Everybody's able. And also, yeah, that looks much better. So we just learned that for IoT projects, we need hardware that produces data, and we need software for hardware. And also on both sides, like on Balena and on Blues Wireless, we do have management or messaging services and cloud-based managing services of hardware, operating systems, and connectivity. And all of them, like Blues Wireless and Balena, allow you to scale your IoT solution in a massive amount, like from 10 devices, one device, or even 100 or 10,000 devices. And they make sure it just works. So, but at the end, you have the data now in the cloud, and you want to store it somewhere, and you want to have like a dashboard. You want to invite your customers and want to make usage of that data. And that's actually something that you do on an IoT platform. There are a couple of them available. You can develop your own IoT platform using some services on the internet, but also you can use Datacake, for example. And Datacake provides a back end and a front end that makes it easy for you to develop your first solutions, but also use our back end, for example, for scaling solutions and bring on your own front end. But for the first steps, Datacake is providing a front end that you can use and build IoT applications pretty similar. Somebody was mentioning it to like WordPress is able to build. You're able to build websites with WordPress, and you're able to build IoT solutions with Datacake. We founded Datacake a couple of years ago. Actually, this year and just a couple of more days, we have our 5th anniversary.
Nice.
And we've been growing in the last 2 years, mainly also because we turned Datacake into an SaaS, software as a service platform. That means you can add any kind of device, LoRaWAN, cellular device, Raspberry Pi running Balena, or any Bear operating system, and you can connect them to Datacake. Datacake brings some kind of features like dashboard designers, where you can drag and drop dashboards and create custom dashboards for your customers. We do have a basic routing, a rule and alerting engine where you can send out emails, SMS, or send downlinks, so actions to other devices, so you can group devices. This is pretty similar to if this, then that. And we also got different kind of options for visualization of data, like asset tracking, but also interactive maps. This is actually showing Blues Wireless application, more on that in a few. And yeah, last but not least, latest widget, which is floor plans. But I don't want to spend so much time on boring presentations and slides. I would like to start, and showing Datacake. If both of you are okay with that, or do you want to show something else on the Balena?
No, it's okay.
Yeah, because then I would just go on and connect the
router.
The Raspberry Pi using Balena onto the nodes, the Datacake.
So yeah, the current situation is we just deploy all the containers with Balena on this Raspberry Pi. It has a node card. It's already registered, this node card on Node Hub, or not yet?
Yes, it is.
No, it's already there. Yeah.
Okay,
We have
so
another project for it.
So we have a project. Actually, we defined on Balena Cloud the name of the product ID and the file ID, that it's data.qo. And so if the data is going to Node Hub, then it's time to create a root.
Yes.
And all you can explain the steps.
Yes, and I will show them now. So thanks, Mark. But yeah, that's exactly what we're going to do now. So as Mark just mentioned, we have everything in the cloud right now. We have it on Balena, and we have data running through cellular. Actually, this is NB-IoT. And this is streaming to the Node Hub, and we're now connecting it to Datacake. So first of all, we need to. This actually what you see is when you register yourself on the Datacake platform, registration is free. You don't need a credit card or something like that. And we support up to 2 free devices. And you can add your first device by using this blue button in here. This will ask you for the device type, and because we're adding something that is already on the internet, we're choosing the API device type, which allows us to connect devices using either HTTP or MQTT. We do have templates, so starting templates that make it more easy to work with existing IoT ecosystems, and we also have an IoT starting template for Blues Wireless. So if you have a node card and you want to start with Datacake, you can use the Blues Wireless node card template in here. You select it, you press on next, and this will ask you for the name of the device. This is the only thing that we are going to enter right now. So we call that IoT Stars, balena Blues Wireless Device 01. Sorry for saying what I'm writing.
It's a short name.
Yes, I was picking the longest possible. I could add Datacake in here, but luckily there's the logo already. Also, we can provide serial numbers on Datacake, so custom serial numbers, because routing on Datacake takes place based on serial numbers. And we are going to use the serial number of that Raspberry Pi here. And for this purpose, I've already opened up the Node Hub. So this is the Node Hub that we were just introduced to by Brandon. And in here, you can see the device ID. And if you click on the device, you can also directly copy it into your clipboard. And we're going back to Datacake and pasting this device in here. So this is now everything that we needed to do to add our first device. We press on next, and we're going to select the free plan. We add this device, and this is now being added to Datacake directly. And you can see this here in the list of devices, and I can now click on the device, and I can see, okay, this was already producing a dashboard for me. We have a couple of tabs over here, and in the configuration, everything that we now need to do is happening here in the configuration. So we scroll down a little bit, and we see the section which is called HTTP payload decoder. And Datacake does not require any special kind of formatting of data or messages that you send to Datacake. We want to make Datacake compatible with all different kind of IoT devices, data structures, and so on. And so we use the concept of payload decoding for LoRaWAN devices, also for HTTP messages and MQTT. And you are designing this little piece of code here, which is executed every time there's a new message. And it extracts the information coming from devices or from different IoT platforms, and then bringing that into Datacake. Also, we've just created a URL for this, an URL for this device, and we are going to use that now as an ingestion point for the data that's been sent from the node card. And we're doing this by connecting the Node Hub to Datacake. And let me copy this one here to the clipboard, and then we are going back to Node Hub. And Node Hub, on the sidebar, you find the routes section, or routes, sort of how you pronounce that correctly. But you can create these routes, and this makes sure that every time there's new data coming from one of your node card devices, this is being routed into the HTTP URL that we are now going to paste in here. So we are going to select general HTTP request response route and call that Datacake, for example. The URL is the one that we just copied. We can leave everything else just like it is, because we don't need to change anything. We create this new role, and this is now hooked up on the Node Hub, and this makes sure that every time there's new messages coming from that device, it's being routed into Datacake. So let's go back to Datacake, and we also can see if there probably is already data being forwarded. No, yeah, there is. We can go into configuration, and I'm just going to quickly reload this page here once more. And under configuration, into the HTTP payload decoder section that I was just showing you, there is this show logs button on the right side. And if we click on that, we can see, okay, there is already data coming from the Node Hub. This is the basic data that's always been forwarded. So it includes some kind of device data from this node card, which is like the cellular location, the cellular tower location, the card, temperature, the card voltage, and all these diagnostic data that you need.
Yeah, in this case, there is tower location, right? Because
Yeah.
this is using the
Exactly.
IoT or cellular
Yes.
communication.
Yeah, and we're also having GPS on there, but I think the GPS won't work here in this location.
Yeah.
Also, there's no antenna attached, but we can use the tower location. And we're also storing them on some kind of Datacake fields. And these are the fields that have been created with the template that we just selected. And in here, we can already see the location. So this is that person on Twitter found out we're at the Zollhof in Nuremberg, but this one is now showing the tower location. So that means that I think it's somewhere over there when I look out of the window. There's a cell tower, maybe on top of that building there. So that's, super interesting to see. If you, for example, have a fleet of node cards, you could use these functions for debugging where they are attached to which kind of cell tower. It's super, great to use. Okay, so let's go onto our dashboard once more, and we can see that these informations are now here being on the dashboard. But we are also interested in some other data, which is the data that the balena device is now decoding from this number, which is right now we're showing
It's
the
7.
Yes,
Change
and
to 6 or 9.
Mark has developed a firmware which is running on the balena, on one of the balena Docker containers, and it's decoding the numbers into actual JSON data and sending it over the node card. And we can see it on the node hub if we go into the events, for example, and then we can see, okay, this is sending us this information here. Label is 7, score is 100. Maybe you can explain what label label is the digit, but score is the probability or the
Indeed. So this machine learning model, what it does, it detects one digit only. So there are 11,000 captures of digits from 0 to 9, and the idea is that we are just getting the score of every digit. In this case, right now it's showing that it detects 6 with 100%. So it's pretty good.
Mm-hmm.
So we didn't need to do anything because it's already on Edge Impulse as an open project that you can clone on your Edge Impulse account for free and test it as well. It's everything. It's documented on the GitHub repo that I shared before.
That's great. Thank you. And let's now find out how to connect this data also, or show it on the dashboard on Datacake. First of all, let's move out on the dashboard designer just to show you this dashboard came with that template, but you're always able to change the dashboard and the design in here. So we're moving out the data, which right now we're not interested in, and we're going back into Datacake, into the configuration, and scroll down to the payload decoder. So this is coming with the template. That means that, as you can see here in the template, there's this section called custom application code. And as Brendan mentioned, the node card forwards data in some kind of files. There's like files. It's just like a name for something like that. Mm-hmm. And there's like a file which holds the user information or the custom code which Mark developed. And we're going to change this decoder actually so that we extract this information. Let's go back to the node hub once more. We can see, okay, this is a JSON, which is holding information label and score. There it is once more, I think. Yeah, it's body, label, and score. Yeah. So that means we can extend it. All the information is in data. And we just simply write something like decoded.score is data.body.score. Because, once more, it's in here. The data is the whole object, and then we access the score by data for the whole object, body.score. We go back into Datacake, and we also do this for the label, which is data body label. And we just add these 2 lines in here, and we can also test this if it's working by simply going back to the node hub. And I think there's an option to copy the whole object in here, right? Somewhere, no, not the read. No, it's not, but it doesn't matter. We can do this from Datacake because
you can get, well, if you want to get, if you go back, there is a text area if you click on one of the events.
Yeah.
And then
Yeah.
Go and then click on JSON. You can select that whole thing.
Yeah.
Exactly.
Yeah, it's manual. We should add a copy
Yeah,
You
why
should.
not?
UI in there. Yeah, I'll put in the feature request right now.
That's great. You can share the live link.
Yeah.
Yes, and you can just paste it here in the body, and then you can simulate the decoder, and then you can see already, okay, it was recognizing the fields like tower location, RSSI, and bars are not being sent from the device right now. Maybe there's some tweaking of the route. But also we got score and label right now. Here in score and label, they are painted or colored red. They're not painted, but they're colored red. And you can click on them, and this asks if a Datacake now asks you if it should create database fields for it. And yes, we do want an integer field for score.
Is this a new feature?
Yes,
Because
this
last
is-
week I didn't see this.
Yeah, this is brand
it's
new.
brand new. Yeah.
This is
Lucas
exciting.
Wow.
is the co-founder of Datacake and the CTO. He's responsible for the development, also for backend and front end. And he was bringing it into the platform during the night. He just mentioned he has a cool new feature. And actually, we were thinking a lot of times doing that because that makes development of decoders more easy.
Oh yeah, that's amazing.
And we
Nice
al-
job, Lucas. If you're still
Yeah.
watching.
Good job. I think he is. And in here, we can also define a role for that field. More on that later. And that's the score. It's just secondary because it's the second important thing. And then we can create also the field for label. Label is the actual number that's been detected by the balena device, and this is the primary role. So we now create these two fields, and we can try the decoder once more. And now both fields are now marked red, so they're created on the database. And you can see them in here. Also, what is new, if you leave the decoder running and you don't simulate it, there you can see now there's a suggested fields option at the bottom. So that means that during runtime, it has recognized a couple of new fields, and you would be able to create them as well. But let's go back to the database section in here, and we can also see that there's already stuff being recorded. And let's go to the dashboard. And now we're going to add like a new widget for whale view, and we're going to select the score. And also we want to make it visually more appealing. So we make like a circular gauge, and this goes from 0 to 100. 100 is good, and the score of 0 is bad, for example. So let's move it and duplicate that once more. And we are going to set this to the number, with the number label. Yes. The label probably doesn't make any sense to have like a page in here, so we're removing this. Yes, and that's actually how we just connected the node card with a few minor tweaks using that template from balena to Datacake. And if mark node changes the number,
Let's do it. Like test, right?
5. Yeah.
I don't know. Let's go to the.
yeah, it takes some time. There is some kind of
Yeah, if you want to share this, let me.
yeah.
I don't know if you have the link of the local. I sent it to you over the private chat.
Yep.
Then you're sharing screen. You can. Oops,
Sorry for that. Yes. Let me see.
Oops, you have to introduce OCR. Let's see if it works. Okay, we have a 5. Yeah, let's see.
Yeah. And we can also see
The
what
only problem is that, yeah, actually this source code, I'm spamming the.
yeah,
We are sending like every
yeah.
100 milliseconds.
We're spending
Stress testing our Node Hub cloud service.
Yeah,
It's
I
fine. It's good.
and Node is still reporting 6 at like 2 minutes ago.
Actually, it's detecting 1, so yeah, I don't know.
Yeah. So we need to wait for it, and then once there is new data on the Node Hub.
Let's do the number 2, maybe. I don't know. Yeah, it's the other way around the camera. Sorry.
Yeah, we try to make like a real-time test, so we're just spamming the cellular connectivity, the Node Hub, and also Datacake. Sorry for that, Lucas. You can ignore the monitors. And yeah, it already shows we're sending too much data. But yeah, let's wait a second. And then once there is a new number, This will update here as well. Yeah.
Yeah, sorry for I didn't have time to change and add like a sleep or something. But yeah.
Now it says 1. And it's recording them multiple times a second.
No, yeah, actually when I changed them, the number, I don't know what number I put, but it detected 1 instead of the other number. Let's see now if the
okay.
I see on the Balena app, on the Balena cloud, sorry, that now the number 2 it's being detected properly. So if we wait just some seconds, maybe we will see the number 2.
Oh, sorry.
No problem.
Too many tabs.
Yeah.
Yeah, and we need but we need
to wait for it to cool down.
Yes, we need to wait for insufficient credits.
I will need that.
Brandon.
We really did spam this thing.
Hold
on. Yeah, well, here, make me an admin.
Okay, we are cutting the workshop here.
Make me an admin on this project, and I'll move it onto our internal billing account.
I don't have any admin rights.
Yeah.
Yeah, but if it
Let
would
me do
be,
that.
we were just sending like multiple events every second.
Yes.
Yeah.
There we go. All right, 1 minute. Edit billing account.
This is my fault, but yeah, this is just demonstrating that this is working really well.
Meanwhile, I can maybe show some other things that we've done with the node card. So actually, Blues Wireless has this node card based device, which is called AirNode, which tracks different kind of air quality parameters, and we've integrated them in the same way to Datacake, and we're visualizing them on one of the tools from Datacake, which is like this air quality map. And as you can see here, we're having many devices on Datacake from Blues Wireless, and they are just measuring PM, so fine dust levels, and also the temperature and humidity and so on, the air pressure. And this is the device actually. It's running on the node card, a node hub as well, and it's forwarding data using the REST API or the HTTP webhook integration we were just showing you. And also, we do have a couple of ways to differently show the data. We can have like a list view and also have like a grid view, which shows you everything directly as an overview to auto-generate these views in here. And we could also do this actually with our Blues Wireless Balena device that we just created in here. Yeah.
This is amazing. So we made it in 1 hour, a little bit less.
Yeah,
a little bit less. Yeah,
a little bit less.
That's very good.
Yeah.
Questions? I don't know if anyone has questions or everyone just left the stream.
Let's see the questions that came up. Oh.
So actually, meanwhile I was working with TJ, who is the developer advocate from Blues Wireless on balenifying, the Blues node card library. What I was thinking is that the node card is a great for Balena devices or for single board computers. It's a great backup connectivity technology.
Yeah.
Because in case you have any problem with your primary connectivity, sometimes it's really interesting to have like a backup connectivity that can just send data or just send any alert that hey, there is this problem on this device. It's under voltage, like we have here, or something is happening. So
and we have some customers that use it for that exact purpose. I mean, if they're using a cellular IoT device and you're in something that's connected to mains power, very likely if that mains power goes out and now you're in battery, the Wi-Fi network is down, but you can use cellular to let somebody elsewhere know that the network is down.
Okay.
The device is now no longer doesn't have power anymore, so the machine is off, or the fridge isn't cooling the product anymore, or things like that. And that is a very, very common use case because you don't have to worry about power outages causing your internal network to go down. You can rely on the cellular network to solve those kinds of things. Yeah. And that's really common too in a lot of LoRaWAN use cases too, where you see a lot of combo Wi-Fi and cellular backhaul. Use one, prefer the other, prefer one and fail over to the other if something goes down. That's really interesting.
Okay, so Jorge is asking actually a question. Yeah, let me just highlight it on the. So what he's asking is, so the information from the Raspberry Pi goes to Datacake through the node card modem. How the Pi and the node card communicate each other? Okay, so let me re-explain because maybe I mis-explained this. The node card modem, it's speaking with the Raspberry Pi over I2C, but actually, because we made the block, you just need to send, let me maybe share my screen. Well, you only need to send an API request, a POST request to node card and the port 32, HTTP node card 3434 port. If you do that and you add like a JSON payload, you're going to send that to the node card blog, and the node card blog is going to have all the Python SDK from Blues Wireless, and it's going to send this data, this payload that you add there, to Node Hub. Then on Node Hub, you just add a route to wherever you want. In this case, it was an API route to balena, to Datacake product, that you created.
Yeah.
And this is how, and then this payload was decoded with the HTTP payload function that you showed before. But basically, this is how it works. So we have this block, which is called node card, and I will share my screen and show it.
And at a fundamental level, whether you're building something with a Raspberry Pi or another host microcontroller, the two options you have for communicating between a host and the node card is either serial or I2C. Yeah. And so it can work with either of those.
I was really fascinated as I was finding it out, because I was trying to understand how the node card works. And first of all, I was thinking like, well, it would be another microcontroller that you can run your code on, and then it sends to the cloud. But then I found out that it's just like a new kind of modem. Sorry if I say modem. It was super easy to connect it to an Arduino or to an ESP32 and use cellular communication and just send JSON to it, and then it was appearing on the cloud. And then I connected it to Balena and also to Raspberry Pi using Node-RED. And I just made a few flows on Node-RED and sent data through the node card. It was just great.
Yeah,
that was really.
It is a modem, but it's a modem with smarts and extra developer conveniences and features. That's the way that I like to think about it.
Yeah,
right? It is provides.
Yeah, and also if you are familiar with developing Arduino applications, for example, like on an 8-bit microcontroller, you can use that with the node card.
Yeah.
And you get NB-IoT connectivity, you get cellular connectivity, the node hub as well, and
yeah. Yeah, because you don't talk about this on the website, but actually, what do you do? So what's the strategy that the node card takes to connect to the internet? So it starts with GPRS, and then NB-IoT, LTE-M1. What do you use?
So we have effectively a secure VPN tunnel from AT&T and their roaming partners networks into our cloud. So that's effectively why we say that data on the cellular node card at least is off the internet, because it goes from cell network over the VPN tunnel into our cloud service, which is hosted on AWS. So
I have suffered roaming cellular devices not connecting to that network and so on. So it's fantastic to have this completely solved. And actually, if you see this diagram that it's now on the screen, actually this is how it works with Balena, right? So you have your service running, you need to send data, so you just post this hub.set that actually Brandon was showing at the beginning of the session with a product, but then you can send data, right? Then you post that to node card 3434, like the port that is exposed on the Docker Compose. And then, the Blues blog just takes care to use the SDK that and sends data through the node card to the node hub. Okay, you just need to add this part on your Docker Compose, this tiny code, just to add this block, expose your I2C interface, and then expose the 34 port, and just give some privileges. We have been testing about that. Actually, if your application is running on network mode host, probably the endpoint for this service is not going to be HTTP node card 3434, but localhost 3434. And we need to test if you don't need the privilege or yes. And this is just.
That's super cool. That's the perfect example on why I love Balena so much, because it's just, I guess you're using Flask to build that, right? Yeah, because it's a web server. Flask is like a web server for high quality web services, and you're actually using some of the techniques built for server applications on a Raspberry Pi, and you're deploying it in the way of a container, and that's something that really
cool.
like about
it's super
balena.
simple.
Yeah, it's really.
We just try to
impressive.
make it super simple
Yeah.
with DJ. So
It's 34 lines of code, and you're using Flask.
Yeah.
Yeah, that's great.
It's like I talked about at the beginning. It's all everything we do is all about removing complexity from what has been
Yeah.
a traditionally
Sure.
very complex, hard to work in sort of space. And I think we were talking before we started recording that we're starting to see a lot more things pick up in the IoT space, and I think a lot of it is because this promise of being able to build simple solutions is being delivered. People can actually finally get stuff, deploy pilots, and get them out there and scale up. I mean, that's exciting to see.
Yeah, absolutely. That's also our mission, to make it more easy. And I remember the first customers that we've had, they wanted to do something with IoT, but they were no developers. They were not having knowledge about IoT in general, and so they needed an easy-to-do platform.
So yeah, that's fantastic. This is a great tool actually to connect devices. And yes, as Jorge says, I know Jorge very well, so I know that he knows all the AT commands for sure for a lot of moments.
Right. Yep.
But yeah, with no AT commands, so you just use REST API, and the AT commands get solved by
You can
by the
throw
engineer.
out that AT commands manual, Jorge, burn it, frame it. I don't know, whatever you want to do. You never need it again.
Yeah, no, and it's interesting because in Barcelona, where I'm based, I don't know why it's connected over GPRS, but here it's NB-IoT, so you don't need to care about these anymore, right?
Same node card, different locations. It figures out where it needs to go.
And you also have this node card LTE, which has not LTE Cat M1, but it has LTE Cat 1.
Cat 1, yes.
Which is in Europe, right now it's, I think, not such a problem anymore, but I remember 2 years ago it was a problem finding NB-IoT or LTE Cat M1 base stations. And then you could use LTE Cat 1, which is similar to NB-IoT or LTE Cat M1. It's not so expensive like a normal LTE modem, but it still works in the same network. So that was really
that's really nice. Yeah.
Also, more questions. I don't know. Yeah, sorry, you wanted to say something?
No. This has been great.
Yeah.
I don't know if there are no more questions. I think it's a good moment to wrap up and just enjoy the nice weather in Nuremberg.
That's right. Well, before we have the main IoT Stars event starting in about an hour. Right?
Yeah, indeed. So we will have another networking event to meet up other IoT professionals coming and trying to explain what we do in our daily lives. And see, and understand if there are other solutions that can help developers and companies to reduce the friction to connect more and more devices to the internet. Yeah, if I don't see more questions on the chat, so I think we're good.
Yeah.
So remember, if you want to use the node card, I don't know if the offer is still on the table, and you can ship a node card to any developer who can suggest an interesting project.
Absolutely.
With balena, Datacake, and node card.
Yeah, shoot me an email at brandon@blues.com or connect with any one of us on social media, and I'd be happy to send you a no card, no carrier. Tell us how you'd use these technologies together, and if you're willing to write about it, maybe do a Hackster project or something. We'll or come on a balena live stream or something. We'd love to hook you up.
Yeah, same here. If you're an IoT developer and you're looking for an IoT platform, we always do support 2 devices for free. But if you have like a non-commercial application and need support from our side, we're open to talk about that. So feel free to reach out to us, and we're happy to support you.
Right, fantastic. So we have no more questions. It was a real pleasure to have again an in-person workshop all together here, kind of fighting in real life, not with the screens.
That's very nice. We'll have to do these again.
Looking forward.
Yes.
Have a good day, everyone, and see you.
Thanks, everybody. Bye.
Bye.